boxes of cheese ring. Produced by, okay, factory A. Up to you. Later when you name it, you get what I mean? There's the population of interest. Okay, so what is the variable that you want to talk about? Our variable, what is the variable that we want to talk about? So the variable is, yes, sodium content in each box. So now are you clear? So you must know the difference between population and variable that you want to talk about. So I let the sodium content be the X. So the variable X, okay, I put here X is sodium content in a box of cheese ring. Okay, so done with the population. And they say that the population, this population, it didn't say it's a standard deviation. It didn't say whether it's normally distributed or not. It just said this population has the mean of 1183 gram. Okay, the sodium content is 1183 gram. Is it a lot? Is it a lot? 1183 gram. Huh. Milligram. That's why I say gram is a lot. Milligram. Scared me. Okay, and the standard deviation of this variable is 88.6 milligram. Okay, when you talk about when you are talking about in your folio, correct? When you talk about this, correct? Actually, this question in a box of, okay, I just give you something. So in a box, you can talk about the sodium content. Then you can talk about the weight of a box of cheese ring. So in here, you can talk about the two variables in the population. Hello? And even you can bring in until 3, in the sense that they produce the ring, correct? Each ring, cheese ring, there are certain amount of weight, am I right? So you can talk about the weight of each individual ring. So in this question, correct, I can talk about if I want to make it as my folio writing, correct, I can have 3 variables involved. I can have the sodium content. I can have the weight of a box. I can have the weight of a ring. And I can even talk about the number of cheese ring that can be in the box. So think of that. When you write your folio, think back this what I have told you here. So I'm just giving you a lot of information first. So don't worry about that. Do you get me? So I'm trying to give you some idea that when you write your folio, correct, you can use some of the question in this textbook to expand it. So as I discuss every question here, I will try to expand for you. So at the end of the day, when you write your folio, correct, you up to you to choose which scenario you want to. Because from the past year, correct, because I didn't give this kind of idea, correct, then whenever come to writing the folio, correct, every one of us is like, don't know how to do. And I have to explain all over again. That will be wasting a lot of time. So do you get me? So whatever examples given in the textbook, you yourself can try to expand it. Okay? So you don't worry about your folio first. You must know. Okay, for this scenario, I can have a few variables of interest about the population. I can talk about the weight of a ring. I can talk about number of cheese ring in that packet. I can talk about the weight of a box. And I can share the sodium content. Okay, so can I not? Okay, so now from here onward, okay, now they say find the probability that the mean sodium content per box for a sample of 50 boxes. That means each 50 boxes, each sample. This is a sample. Got how many boxes inside? 50 boxes inside. Have you ever buy things like that in a big box? Huh? Yeah, there are 50 small boxes inside. Okay, so this is a sample. So now for this, we assume that all these boxes that is putting into a big sample there, they are random sample. They are random sample. You can imagine in a factory how many boxes they produce per day. Have you ever wondered how many boxes they produce per day? Yeah, so this is sample mean distribution. Okay, so what is the sample size? How Xuan? Huh? 50. So the n is 50. So I want to find the probability that sample means distribution. So I put x bar 50, okay? So my x bar 50 is between 115 and 1200. Okay? So I want to know this. So how to count this? How to count it? Yes, Rachel. How to count this value? How to count this value? Why? Can I use normal? Can I use normal CDF? Kevin? Why can? You cannot just simply say, okay. I did say the population is normally distributed one. Okay, Avika, why can? Cannot say not sure. By now, if you are not sure, that means something wrong already. Faster. Yes. 1, 2, 3, 4 sana. Siapa nak jawab? Yes. You see, according to central limit theorem. So for me, if the question asks, can you approximate, can you say that the sample mean distribution for this case is approximately normally distributed? Yes. According to central limit theorems, if the population is not normally distributed by rules of thumb, n equal to 50, which is greater than 30, then the sample mean distribution will be approximately normally distributed. Hey, please memorize by heart. So everything we call central limit theorem. Are you clear? Everything you call central limit theorem. So if I ask you, is this sample mean normally distributed? Explain. So you have to. So whenever you write your folio, also the same. You don't know whether the population is normally distributed or not. So when you take your sample size, you should take we should take what? N greater than 30, correct? According to central limit theorem. Okay, are you clear? So please take note of that. I'm repeating this at least 10 times already, Kavan. Mr. Repeat this at least 10 times already. So be very careful, Be very, very careful. This part. Which variable are you talking about? Are you talking about the population variable X, or are you talking about the variable of sample mean? I write double the mean. Okay, can or not? Okay, good. So let's go to question 11. So I have a sample. That means on a particular day, I got 37 customers. Enter the shop, for example. Okay, 37 customers enter the shop. So now I'm trying to find sample mean. So is this sample mean normally distributed? Yes. Why? Because according to central limit theorem, the population, it doesn't mention whether the population is normally distributed or not. So by rules of thumb, 37 is greater than 30. So therefore, the sample mean time of a customer enter this store is normally distributed, correct? So this is normally distributed. Okay, you know the reason, am I right? Okay, got it? So now you can find the probability. So probability of X bar 37. So for this one, your variable of interest is the sample mean time of a customer with the sample size of 37. When 37 customers enter the shop, what is the sample mean time? Okay, the probability of the sample mean time between 17 and 20 will be, okay, please take out your graphic calculator and calculate. And please write down the normal CDF also, everything, write down clearly. Yes, Christopher, answer. Since you are chit-chatting, you got time to chit-chat means you have get the answer already. 0.8636, correct or not? Okay. Christopher, tell me, what must I write? Normal, CDF, some more? 17, 20, 18, 5.3 over root 37. Done. Got it? Okay. So through these two questions, I've taught you how to look at the population, how to look at the sample. So the sample mean for 37, okay? The sample mean of a customer, the sample mean is the sample mean, the mean time of a customer that will enter the shop when the sample size is 37, right? So the probability definitely higher, all right? So the kind of whether it's higher or lower, that one we discussed yesterday, so I won't discuss today. So when you are writing your folio, you also can plot the graph. You can also talk about which one will be higher, why is it higher. You can do all the explanation. Okay, so you please try question 12. We try it, right? So 13, 14, 15, 16. Yep. And 16 is also one of the questions whereby you can do it in Taylor College itself. About the leaf. You just sit there and look at it. Or you ask one by one who come into the leaf, what is your weight? You see or not? Okay, you get what I mean? Okay. So I'm just giving you some suggestion. Okay, thank you, class.